All right, good morning. We're looking at 8.4.1. What if it has infinitely many sides, a special ratio? In section 8.2, you developed a method to determine the area of a regular polygon with n sides. You carefully calculated the area of regular polygons with 5, 6, 8, and even 10 sides. But what if a regular polygon has infinite number of sides? How can you predict this area? As you investigate this question today, keep the following questions in mind. What is the connection? Do we see any patterns? How are the shapes related? So we want to keep those three questions in mind for 877. Polygons with infinitely many sides. To predict the area and perimeter of a polygon with infinitely many sides, your team is going to work with other teams to generate data from different polygons and then look for a pattern. For each polygon you are assigned, calculate the area and perimeter if the radius is 1 unit, as shown in the diagram of the regular pentagon above. So notice this is the radius of the polygon, right? Record your answers accurate to the nearest 0.01. Place your results into a class table to help predict the area and perimeter of a polygon with infinitely many sides. Now, this is an exercise that I really like doing because in class, what I would normally do is each group would be assigned one of these. Some groups, actually, I'd probably put you in pairs, and one person would do one group would do one and the other group would do the other. And so consequently we would find the area and perimeter of all of these polygons listed below. And then what I would do is I would have a table up on the board that you would input your answers. So what I thought I'd do is I'm going to do three of these. I'm going to find the area and perimeter of the equilateral triangle using our regular polygon method, and then I'm going to find the area of a regular 15-gon and a regular 180-gon. So starting with finding the area of an equilateral triangle, remember our equilateral triangle has three equal sides. We know, oopsie, sorry about that guys, we know that each of these angles here are 60, and we know that we have the radius going here, and we know that this is going to be 30 and this is going to be 30, and then this is going to be 90. Here is my height, here is my base. Now you need to remember, how many triangles do I have in here, right? So I have 1, 2, 3. So my area is going to be A equals 3 times 1/2 base times height. Now, some of you guys are saying, well, Miss Fifield, I know that I can find, if this is 60 and I know this is 30, I can kind of work backwards to find the area of one of these triangles. But I'm going to use the area of a regular polygon, and so with doing that I know I have three triangles that are going to be congruent. So now what's left is I need to find in my triangle, I know this is 30, and I know this is 60, and I know this is 1, this is the height. I know the base, if I reflect this triangle, this is the whole triangle. So I know if I know this length here, I know this length, and then I know the entire base, which is what I need to know. So what I'm going to use is I'm going to use special right triangles because it's a 30, 60, 90 triangle. I know when I go this way I multiply by 2. When I come the other way I know I divide. So that's going to be 1/2. And then I know when I go from here to here I'm going to multiply by √3. So then I know this length is √3/2, and I know that this length here is going to be √3/2, right? Because you're going to have 1/2 times √3, and when you do that, that's over 1, and so then that's why it's going to be √3/2. So now, because they both have the same common denominator, we know that the base is going to be 2 root 3 over 2, and then the 2's cancel, and so the base is going to be root 3. So we know the base and we know the height, so now I can plug it into my formula here, and I get a equals 3 over 2 times root 3 times the height, which is 1/2. And so just doing some math here, 1/2 times 3/2 is going to be 3 over 4, and then times root 3. So this is an exact answer, right? And they asked us to round to the nearest hundredth, so I'm just going to use my calculator, and I'm going to do 3 times root 3 equals, and then I'm going to divide that by 4, and I get 1.299, and so they wanted me to round to the nearest hundredth, so then this is going to be 1.30, and that is my area. Now the next thing they wanted us to do is they wanted the perimeter, and so I know the perimeter is going to equal 3 times what's b equal to, root 3, and so the perimeter is going to be 3 root 3, which again they want, that's the exact answer, and the approximate answer is going to be 5.196. This rounds it up, so my answer is going to be 5.20. Now remember, you need the 0 because that's telling us I rounded to the nearest hundredth. So there is the perimeter. All right. So now that wasn't too bad, but now we want to find the area of a 15-gon. Now, most of you guys know when I do these problems, what I do is I can't draw a 15-gon, but I know that there are going to be 15 of these triangles, and so this is kind of what I'm working with, and I know that the area of this is going to be 15 times 1/2 base times height. And then I know, just kind of to do some math, 15 times 1/2 is going to be 7.5, so then this is going to be 7.5 base times height. Now what I need to do is I need to get, I know this is going to be the base, and I know that this is going to be the height, right? So I need to get the base and the height, but before I can do any of that, because I'm going to need trig for this, I need to find angle measurements. Again, I feel like the easiest way to do this is to take 360 and divide by 15, and so when I do 360 divided by 15, I get 24, and then you take 24 and you divide it by 2 and you get 12. And so the reason I'm doing that is when you look at this triangle here, this is going to be, I want to use a different color here, this is going to be the height, right? And I know that this is going to be 12 and this is going to be 12. And then I can work backwards, because if this is 12 and 90, I can take 90 minus 12 and I get 78. Now, you could also use the n minus 2 times 180 and then divide it by n, and that gives you the interior angles. Or you can use the fact, you know, the exterior angles, you can use that as well. Being that we know the exterior angles add up to 360. So, and you can divide that by the number of sides that the polygon has. So anyway, either one of these will work. I just feel like finding this angle here is the easiest. Okay, so then we know this is 78. So now I need the height, And so then I know the height is going to be equal to, oh, and I forgot a measurement. This is 1, and we know the radius is going to be 1. So we know that the sine of 78 is going to equal h over 1, which is just the sine of 78 equals h, right? And then we know that this is a and this is a, and we know the whole length here is going to be what? B. And so I could use the cosine of 78, but I'm going to use the sine of 12. And the sine of 12 is going to be a over 1. So then that tells me that that length is going to be sine 12 equals a. Now remember, this is just one side. I want the whole length. So realize, if this is sine 12, then this is sine 12. So when you add two sine 12s, that's going to be 2 sine 12 equals b. So I now have the height and I have the base, so then I can plug them into my formula here, and I get a equals 7.5 times the base, which is 2 sine 12 times sine 78. And now it's just a calculator problem, so I key it into the calculator, make sure your mode is in degree. And so 7.5 times 2 sine 12 times sine 78 equals, and so I get the area is equal to 3.05 units squared. And so that's my area. And then the next thing that they want you to find is they want you to find the perimeter. Well, the perimeter is going to equal, how many sides do I have? I have a 15gon, so it's going to be 15 times whatever b is, and I know that b is going to be 2 sine 12. And so again, I'm going to key that into the calculator, and I get 15 times 2 sine 12 equals 6.23. So it's actually 6.237, which that rounds to 6.24. And that's my perimeter. And then what you would do is you would put that up in your we would put that in the table up on the board. So then we have the 180 gon. And so when we have the 180 gon, again, my strategy is exactly the same. I'm going to create this triangle. I know that this is going to be the base, and I know this is going to be the height, and I know that there's going to be 180 of these triangles. So I'm going to take 360 and divide it by 180, which is 2, and then when you take 2 and divide it by 2, you get 1. So that means looking at the information in my triangle here, this is my height and this is my base, and I know this is going to be 1, and I know the radius is 1. So now they tell me I know this measurement here is 1 unit, and so if that's 1 unit, I know this has to be 89 degrees. So now I'm doing the same thing. I know to get the area, it's going to be A equals 180 times 1/2 base times height. And just to simplify that, that'll be 90 times the base and the height. So just like the 15gon and just like the equilateral triangle, I need to find the base and the height. And so, and because I don't have special right triangles, I have to use my I have to use trig. So again, when I do this, I am going to I'm finding the height. So the height is going to be sine 89 equals h over 1, which the 1 just cancels out, right? So then we get sine 89 equals h. Okay, so now I have the height. So now I need the base, and so I need to find what a is. So to get a, I'm going to use 1, and I'm going to do the sine of 1. And again, you could do the cosine of 89. I just feel like this is a little easier. The sine of 1 is going to equal a over 1, which the sine of 1 equals a. And so remember, if this is sine 1 and this is sine 1, to get b I have to add them together. So to get b, that is going to be 2 sine 1. And so that's what my b equals. So now I have the height and I have b, so now I just have to plug it into my formula, and so I get 90 2 sine 1 times the sine of 89. And so then a equals, so now I'm just keying into the calculator, making sure my mode is in degrees, and then I do 90 times 2 sine 1 times sine 89, and I get my area is 3.14 units squared. And then the last thing I have to do is find the perimeter. Well, I know the perimeter is going to be 180 sides times whatever b is, and so then the perimeter is going to be 180 times 2 sine 1, and so the perimeter is going to be equal to 180 times 2 sine 1, which is 6.28. So it's 6.282, which it doesn't round up, so the perimeter is going to be 6.28. And there you go. So these were kind of complicated to do. So now in class, what we would do is we would have these up on, I would have this up on the board. And so we did 3, we did the 15 gon, and we did the 180 gon. Now, one of the things that's interesting to note is as you look at this, what's happening with our table. As the sides of the polygon increase, right, as they become infinite, what are they starting to become? What's 3.14? That is pi, right? And then when you look at perimeter, the more sides we get, right, we get to 15, 30 sides, 6.28, we get to 60, now we are 6.28, and what is that the same thing as? 2 pi. So as a polygon approaches infinitely many sides, what is your shape becoming? And hopefully you guys see that this is becoming a circle.